So our final standard for grade 8 is standard 4. In this standard, we are working with patterns of association that can be seen in bivariate categorical data. So it's bivariate again, but the difference here is that it's categorical, and by displaying frequencies and relative frequencies in a two-way table. Construct and interpret a two-way table summarizing data on two categorical variables collected from the same subjects. Use relative frequencies calculated for rows or columns to describe possible association between two variables. So relative frequencies are calculated as percent. So let's do an example problem that kind of displays this standard. So we're looking at height of corn. So perhaps a farmer is interested in whether the type of soil makes a difference in the height of the crop of corn. So here we have a table representing the planting of 2,500 stalks of corn, and this table here is called a frequency table. It's showing the counts or frequencies in each of the cells. So for example, planted in sandy soil, there were 150 stalks of corn between the heights of 0 and 3 feet. This data, we might want to make a conjecture about whether there's a connection between the type of soil and the height of corn. So, looking at the data, could we guess? Is there an effect of the type of soil on the height of the corn? Well, if I look across all of this, I see that in the sandy soil, there are more taller stalks, and it's about the same across for the clay soil. But making that judgment by just looking at these numbers can be a little bit difficult. So to make the information a little easier to look at, we can easier to analyze, we can take this categorical data and look at it in terms of percents. So to do that, we need to figure out how to calculate the percent. We need to figure out which is our independent and dependent variable. More specifically, though, the appropriate vocabulary for statistics is the explanatory and response. So in this case, our explanatory variable is the sandy or clay soil, the soil type, and our response is the height of the corn. So if translated into dependent and independent, the dependent is the type of soil and the independent is the height of corn. So once that's been determined, we can figure out how to calculate the percents. With that determination, for example, we're going to be calculating 150 out of this total as opposed to the total of number of stalks in between 0 and 3. We're going to be 150 of that height out of the total planted in sandy soil. So is the table of percents calculated from this. So the 9% here comes from 150 divided by 1,675, and 200 divided by 1,675 gives us our 12%. So from here we would want to make two bar graphs, one for each of our explanatory or dependent variables, one for our sandy soil and one for our clay soil to give a comparison. So some questions or topics that might come up with this problem with students is, why can't we use a histogram for this? Why are we using a bar graph instead of a histogram? Because if you look at the table, it looks like we've got bins set up, but this is actually categorical data. It is not, these are not bin widths. Notice that from 0 to 3 feet is not the same bin width as 3 to 4 and 4 to 6. These are categories, so we need to treat them as bar graphs. So to build this bar graph, So I'm going to be labeling the bottom here with our categories. So we've got a 0 to 3, a 3 to 4, and a 4 to 6, and a 7 to 8. So there's the rest of it labeled, fast forward. So we can use our percent. So these frequencies are the percents. So we've got for our sandy soil, 9%. So we can put a bar approximately here. And for our 3 to 4 feet height, about 12%. And for our 4 to 6, 34%. Forward a bit again, and here we have all of our relative frequencies graphed on 2 separate bar graphs. So now we can compare what association is the height of the corn associated with the soil type. Well, the conclusions we could make here is that the sandy soil clearly has a larger frequency, or larger relative frequency of taller corn, and there does not seem to be any association with sandy soil. There is approximately an equal number of each height grouping for the sandy soil. Good example of the majority of what's happening with Standard 4. Next, I'd like to talk about a nice summary that could be done with 8th graders after going through all of the data and statistics part. A nice summary of this is taking a look at what are all of the displays that are possible for numerical data, because now once we've gotten to 8th grade, we've looked at single variable data, we've also looked at 2 variable data. So what kinds of displays are there available for numerical data? Well, our typical display for numerical data with single variable would be the dot plot, the histogram, and the box plot. And for 2 variable data, our typical is a scatter plot. Another question to discuss is, what about displays for categorical data? Well, single variable categorical data is most typically done in a circle graph, and that's something that can be reviewed and worked on in 8th grade, and as well as bar graphs. And for 2 variable data, 2-way tables that like what we just looked at, and using multiple bar graphs for a bar graph each for each of the explanatory or dependent variables. And descriptions of numerical data. So what are the different ways that we have learned to describe types of numerical data? Well, for single variable data, we've learned to describe center, our mean or median, and our IQR, also as well as the shape of the information. Is it uniform? Is it single-peaked, double-peaked? Does it have symmetry? Is it skewed? Also the spread of the data. What is the range? What is the interquartile range? What is the mean absolute deviation? And are there any outliers? When we're dealing with 2 variable data, that's typically looking at a scatter plot. So we're looking at the form of the data. Is it linear? Is it curved? Is it just scattered with no association? Also the direction of the association. Is it a positive or negative association? And then the strength of the association. Is it very, very close to linear or very loosely linear? So a strong or a weak association. And then again, are there outliers? So that pretty much sums up the majority of the ideas in the 8th grade data and statistics.